When dealing with fire system wiring and a 240-volt circuit without a neutral, there are several possible scenarios to consider. Firstly, it's possible that the fire system requires a neutral wire for its operation. If this is the case, your current wiring configuration, which consists of two hots and a ground, is incompatible. You will need to run an additional neutral wire from the electrical panel to the fire system box. Secondly, some fire systems utilize an internal step-down transformer. These systems may have an internal step-down transformer that converts the 240 volts input to a low voltage such as 120 volts, which may not require a neutral wire. In this scenario, you might not need to run a neutral wire. However, it is crucial to verify this information with the fire system manufacturer or the installer to confirm whether a neutral is indeed not needed. Thirdly, it's important to consider the possibility of incorrect wiring instructions. The information provided by the fire system installer might be inaccurate, so it's essential to double-check the wiring diagram or use a manual for the fire system to ensure that a neutral wire is not required. To address this situation effectively, there are several recommended actions you should take. 1. Contacting the fire system manufacturer or the installer directly is the best approach. They can provide accurate information on whether a neutral wire is required for the system's operation and advise you on the appropriate wiring configuration. 2. If the fire system requires a neutral wire, you will need to run an additional neutral wire from the electrical panel to the fire system box. Ensure that the wire is properly sized and installed according to all applicable electrical codes. 3. Regardless of whether you run a neutral wire or not, it is crucial to verify the proper wiring. Once all wires are connected, carefully verify that the wiring is correct by performing a continuity test. Use a multimeter to test for continuity between the appropriate terminals on the melter and the fire system box. To elaborate further on these points, let's delve into the specifics of each scenario. If the fire system unequivocally requires a neutral wire, the absence of one will prevent it from functioning correctly. A neutral wire provides a return path for the current, allowing the system to complete the electrical circuit. Without this return path, the system will not receive the necessary power to operate. When running a neutral wire, it's imperative to adhere to electrical codes and safety standards. Firstly, the wire gauge must be appropriate for the circuit's amperage. Consult the National Electrical Code, specifically Table 310.15b16, to determine the correct wire size based on the ampacity of the circuit. Secondly, the neutral wire must be properly connected to the neutral busbar in the electrical panel. This busbar is typically identified by a white or grey color and is where all neutral wires in the electrical system converge. Thirdly, ensure that the neutral wire is securely connected to the fire system box, using appropriate connectors and following the manufacturer's instructions. In the case of a fire system with an internal step-down transformer, the transformer reduces the 240 volts input voltage to a lower voltage, such as 120 volts, which is more suitable for the system's internal components. Some step-down transformers are designed to operate without a neutral wire, relying instead on the two hot wires and a ground for power. However, it's crucial to understand the specific requirements of the transformer and the fire system to ensure proper operation. Firstly, consult the fire system's technical documentation to confirm whether a neutral wire is required when using the internal step-down transformer. Secondly, if the documentation is unclear, contact the manufacturer directly to obtain clarification. Thirdly, if a neutral wire is not required, ensure that the transformer is properly grounded according to electrical codes. This grounding helps to protect against electrical shock and ensures the safe operation of the system. If there's a possibility of incorrect wiring instructions, it's essential to approach the situation with caution. Firstly, do not rely solely on the verbal instructions provided by the fire system installer. Secondly, obtain a copy of the fire system's wiring diagram or user manual. Thirdly, carefully review the diagram to identify the correct wiring configuration, paying close attention to whether a neutral wire is required. If the wiring diagram is ambiguous or difficult to understand, seek assistance from a qualified electrician. A licensed electrician has the knowledge and experience to interpret electrical diagrams and ensure that the wiring is performed correctly and safely. When contacting the fire system manufacturer or installer, be prepared to provide them with specific information about your electrical system and the fire system model. Firstly, have the fire system's model number and serial number readily available. Secondly, describe your existing wiring configuration, including the voltage, number of wires, and the presence or absence of a neutral wire. Thirdly, clearly explain the problem you are encountering and the questions you have regarding the wiring requirements. By providing this information, you will enable the manufacturer or installer to provide you with accurate and helpful guidance. When running a neutral wire, ensure that you follow all applicable electrical codes and safety standards. Firstly, disconnect the power to the circuit at the electrical panel before beginning any wiring work. Secondly, use properly insulated tools to prevent electrical shock. Thirdly, carefully route the neutral wire from the electrical panel to the fire system box, avoiding any sharp bends or kinks in the wire. Fourthly, secure the wire using appropriate cable clamps or staples to prevent it from becoming damaged or dislodged. Fifthly, when connecting the neutral wire to the neutral busbar in the electrical panel, ensure that the connection is tight and secure. A loose connection can create heat and potentially cause a fire. Sixthly, when connecting the neutral wire to the fire system box, use appropriate connectors that are designed for the wire gauge and type. Lastly, after completing the wiring, double-check all connections to ensure that they are secure and properly insulated. Verifying proper wiring is a crucial step in ensuring the safe and reliable operation of the fire system. Firstly, use a multimeter to perform a continuity test between the neutral wire and the ground wire. There should be no continuity between these two wires, as they are separate conductors. Secondly, use the multimeter to test for voltage between the hot wires and the neutral wire. You should measure approximately 120 volts between each hot wire and the neutral wire. Thirdly, use the multimeter to test for voltage between the two hot wires. You should measure approximately 240 volts between the two hot wires. Fourthly, visually inspect all wiring connections to ensure that they are tight, secure, and properly insulated. Lastly, after completing the wiring and testing, energize the circuit and verify that the fire system is functioning correctly. If you encounter any problems, such as the system not powering on or tripping a circuit breaker, immediately disconnect the power and consult with a qualified electrician. In addition to these specific steps, it's important to consider some general safety precautions when working with electrical wiring. Firstly, always assume that all wires are live, even if you have disconnected the power at the electrical panel. Secondly, never work on electrical wiring while standing on a wet surface or while your hands are wet. Thirdly, wear appropriate personal protective equipment such as safety glasses and insulated gloves. Fourthly, if you are not comfortable working with electrical wiring, do not attempt to do so. Contact a qualified electrician to perform the work for you. Furthermore, always consult local electrical codes and regulations to ensure that your wiring is compliant. Electrical codes are designed to protect people and property from electrical hazards, and it's essential to follow them carefully. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical wiring and safety. When in doubt, consult with a qualified electrician or electrical inspector to ensure that your wiring meets all applicable code requirements. Remember that electrical work can be dangerous, and it's essential to take all necessary precautions to protect yourself and others. If you are not experienced in electrical work, it's always best to hire a qualified electrician to perform the work for you. A licensed electrician has the knowledge, skills, and experience to ensure that the wiring is performed correctly and safely. Finally, always keep accurate records of all electrical work performed, including wiring diagrams, test results, and any modifications made to the system. These records can be helpful for future troubleshooting or maintenance. By following these guidelines and taking the necessary precautions, you can ensure that your fire system wiring is safe, reliable, and compliant with all applicable codes and regulations. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. In addition to the steps outlined above, it's crucial to understand the function of a neutral wire in a 240-volt circuit. A neutral wire provides a return path for the current, allowing the circuit to complete its loop. In a typical 120-volt circuit, the neutral wire carries the unbalanced current back to the source. However, in a 240-volt circuit, the neutral wire is not always required. Some 240-volt appliances and equipment, such as electric heaters and air conditioners, operate solely on the two hot wires and a ground wire without requiring a neutral wire. These devices use the voltage difference between the two hot wires to power their operation. However, other 240-volt devices, such as electric ranges and clothes dryers, require a neutral wire in addition to the two hot wires and a ground wire. These devices typically have both 240 volts and 120 volts components, and the neutral wire is used to provide the 120 volts power for the smaller components, such as the control panel and lights. If your fire system requires a neutral wire, it's essential to understand how to properly connect it to the electrical panel. The neutral wire should be connected to the neutral busbar, which is typically identified by a white or grey color. The neutral busbar is connected to the grounding electrode conductor, which runs to the grounding electrode system, such as a ground rod or a metal water pipe. The grounding electrode system provides a path for fault current to return to the source, helping to protect against electrical shock. When connecting the neutral wire to the neutral busbar, ensure that the connection is tight and secure. A loose connection can create heat and potentially cause a fire. Use appropriate connectors that are designed for the wire gauge and type. It's also important to ensure that the neutral wire is properly sized for the circuit's amperage. The wire gauge should be sufficient to carry the maximum current that the circuit is expected to draw. Consult the National Electrical Code, specifically Table 310.15 B16, to determine the correct wire size based on the ampacity of the circuit. Using a wire that is too small can cause it to overheat and potentially start a fire. In addition to the neutral wire, the ground wire is also an important safety component in a 240-volt circuit. The ground wire provides a path for fault current to return to the source in the event of a short circuit or other electrical fault. The ground wire is typically connected to the metal enclosure of the electrical equipment and to the grounding electrode system. The ground wire should be properly sized for the circuit's amperage and should be connected to the grounding electrode system using appropriate connectors. It's also important to ensure that the ground wire is properly bonded to all metal parts of the electrical system, such as metal conduit and junction boxes. Bonding ensures that all metal parts are at the same electrical potential, reducing the risk of electrical shock. When working with electrical wiring, it's always best to err on the side of caution. If you are unsure about any aspect of the wiring, consult with a qualified electrician. A licensed electrician has the knowledge, skills, and experience to ensure that the wiring is performed correctly and safely. Electrical work can be dangerous, and it's essential to take all necessary precautions to protect yourself and others. By following these guidelines and taking the necessary precautions, you can ensure that your fire system wiring is safe, reliable, and compliant with all applicable codes and regulations.